right, I think the next thing we want to do is generalize this concept. What concept I'm talking about? I'm talking about applying a filter. So let's create something. Let's create a protocol. So any object can expose this protocol. Let's call it filter. So I'm going to go new. I wanted to go. Oh yeah, new file. And a Swift file, yes indeed. And I'm going to call it filter. Right. So what is a filter? A filter is a protocol. Okay. And it's a protocol that basically has one function at the moment called apply. Okay, and what do? The input to this function is one of those images, and the output is also an image. So that's actually pretty simple stuff. If you have a filter, you can use the apply method to take an image and give you an image back. Okay, so that's the general design. Why don't we create another file that has one or more of these filters? And we're going to imagine that it'll eventually have a few of these filters. So I'm going to call this file filters. Okay, so in filters, we're going to start with one. I'm going to create a class. And let's do something similar to this, but a little more flexible. Let's call it a scale intensity filter. Right? Okay. And it implements the filter protocol. Okay. And so it has to be a function. It has to have a function called apply. Nice. Look at all the code completion happening for us, happening there. Okay. So we need to take an image, return an image. The bare bones of this, if the filter did nothing, we could just return the input. And that should be syntactically correct. Yep, it looks like it's syntactically correct. But of course, we don't want to do that. We actually want to transform the input. So instead, you've got the input, and we want to do transform pixels. Once again, ooh, look at that. Use that nice completion mechanism. So transform pixels takes a function which takes a pixel and returns a pixel. And this is shorthand notation for that. So let's call this input pixel P. And the code for doing that is, first of all, I'll call this P1. This is our input. I'm going to say let P equals P1. So we've taken a copy. Then we do some stuff with P, and then we return it. Okay, and it's nice. Okay, that's syntactically correct, but we haven't done anything yet. We haven't scaled it yet. And this is where I'm going to do something a little different than our half intensity. Instead, when you create a scale intensity filter, I'm going to say, oops, actually we want the initializer to take a value called scale. And that's going to be, I'll say it's a double. So it's a value between 0 and 1. And all we're going to do is we're going to store that locally. So we're going to have let scale, and it's a double, right? So in our initializer, we'll go self.scale equals scale. Okay, so what can we do with all this? Well, I would like to make the red equal to, okay, we're going to take the existing red value and we're going to transform that into a double. And we're transforming it to a double because we're going to multiply it by the scale, right? Okay, and then this all has to be transformed back to u int 8 again. Nice. Okay. Oh, did I get any syntax errors? It is whining about something. Ah! My usual problem, it is a variable because we are mutating it. And scale has to be self.scale if I remember, because we're inside a closure. Yes. Great. Okay, just make that green, green, blue, blue. Okay, so there's one filter. Let's create one more filter just so I have a couple going here. I'm going to call this mix filter. Why am I going to call it mix filter? Because I'm going to take the original red value, so I'll go p.red. I'm going to store that, and I'm going to say p.red is equal to p.blue, and we're going to say p.blue is equal to p.green. You can kind of see the design here, I think, and then I'll say p.green is equal to the original R. So this is going to mix the red, blue, and green. It's going to take what was one and make it the other, so it should really mix up our colors for us. This really doesn't make any sense, but it's nice to test with. So let's go back to our controller, and if we did everything correctly, we should now be able to do something like this. So we're not going to call transform directly anymore from here, nor do we need this half intensity filter anymore. Let's just get rid of stuff. Instead, we are going to take the image. We're going to create let. I'll say F1 is equal to, we'll start with the mix. The mix filter. Oh, did I call it the right thing? Sorry, bear with me a moment. Yes, I did call it mix filter. So let's go back again. F1 is equal to the mix filter. Right? F1 dot apply. Okay, we want the image. And that should give us an image back. Oh, and let okay, and what did I get wrong? Probably, I'm thinking it has to be public, and I didn't make it public. What did it say? Oh, for scale. Right. I copied everything even though I didn't need to. There we go. The mix filter doesn't need a scale. So going back to here. Yay. Okay, so we are expecting if we run, we're going to get some pretty messed up colors. So let's run it. What was red becomes blue. Yeah, there we go. That's pretty messed up. I like it, the alien look. Okay, now if everything's right, we should be able to, apply multiple filters. So I'm going to say let F2 equal to our scale intensity filter, and let's set the scale to 0.25. So this will really dim up the image for us. So what I'm going to do is I'm going to apply multiple. I'll make it easy to read. Let image 3 is equal to filter 2 dot apply, right? And we want to take image 2, right? And then finally we want this. Okay, so we should see those weird colors, but at 1/4 the intensity, so it should be really washed out. Let's give that a shot, see if it works. And if it does, then we can move on. Yes, so we got our messed up colors and everything's very washed out, which is what we expect because we mixed up the colors first and then we scaled the intensity. Alright, I'm going to check this in and we'll move on. So let's commit. And what have we done? We have added multiple filters.